Alright, Chapter 5 starts off with bivariate data. So, what is bivariate data? Actually going to define bivariate data and univariate data together. So, univariate data are measurements of one variable. To understand the relationship between two variables, data on both variables needs to be collected. Alright, so if you collect data on two variables to help figure out some relationship, if there is one, that type of data is called bivariate data. So, for example, think about it kind of like this. What if I went outside in the parking lot and I had a chart of all the just the basic colors that cars can be, and I went around and I tallied up how many red cars, blue cars, green cars, white cars, gray cars, black cars, and so on and so forth. Alright, so I've just collected data on one variable. What color is the car? But let's say that I also somehow could figure out how many tickets each car had. Like how many tickets the person that drives the car had. And maybe blue cars had a certain number, maybe red cars had a certain number, and so maybe then I could try to develop some relationship between the color of a car and how many tickets that have been written for the person driving that car. Now that probably would have no type of relationship at all, but who knows, it may, over time it may, but that was just something just popped into my head. But if you have to collect data on two different variables, then that's called bivariate data. So it's a pretty easy concept to understand. Your ebook does this. It takes all of the states, or at least some of the, I guess not all of them, but some of the states. Maybe it continues on the next page. No, it doesn't. Yeah, it does. Okay. I just wanted to make sure we could get to Mississippi. Alright. It takes all of the states and then the high school completion percentage and the crime rate per 100,000 people. Alright, and so it is this table, you have two variables, and maybe they're trying to compare if raising the high school completion rate would lower crime rate or something like that. So you see Mississippi here, 60.8% high school completion rate. And this was in 2000. You don't see many below that. I mean, there are a couple. It's at least we beat out Louisiana and Tennessee, but we didn't come anywhere close to some like Iowa, Connecticut, Minnesota, Nebraska, New Jersey. See, those have pretty high graduation rates. And so if there was just some way that we could display that data and help us look for a relationship or a trend, then that would help us predict how education or completion of education ties into crime rate. It may not. But that's just an example of the bivariate data. Okay? And so one way of displaying that data is by using scatter plots. And this is 5.2. Alright, a scatter plot, and you may also see it called a scatter diagram, but probably you'll just see it called a scatter plot. A scatter plot scatter plots are the traditional graphical method used to display the relationship between two variables. Alright, so what does a scatter plot look like? If you think about, and it doesn't always have to be the positive x and positive y axis, I guess. There could be other types of or variations of scatter plots, but generally you'll have one variable on the horizontal axis and one variable on the vertical axis. Now here they put x and y there excuse me, because that's kind of what you're used to. You're used to x and y. And so if we were to take and plot data, maybe education percentage along with crime rate, kind of like a ordered pair, an x and a y, then we could tell some type of relationship maybe between the two variables. Now this scatter plot doesn't go with any table, any values that we've been given, but this scatter plot represents a positive relationship because the slope is positive. Alright, whenever the slope of, say, an imaginary line that goes, it doesn't have to go through every point, but an imaginary line that goes through the concentrated area of points, we'll get to that, what that's called. But of course if you go up, left to right, that's a positive relationship. And then if you go down from left to right, the relationship is negative. And your book says that's called an inverse relationship. Okay, so you can tell it's going down from left to right. That's called an inverse relationship. And that relationship is negative, just like the slope of the line would be negative. There are a few other examples in your book that you really can't tell, you know, especially on scatter plot 3, really doesn't look like much of a relationship. But 4, this one here, I mean, they're grouped up a little closer, so we could draw some line here and kind of predict. It does appear, it's not real apparent, but it does appear as the x variable gets larger, so does the y variable. So maybe if this was education and crime rate, maybe as the percentage of education completion goes up, the crime rate goes up. That's probably not right. You know, this is probably maybe something different, because you wouldn't want that to happen. You wouldn't want more educated criminals out there. But yeah, up left to right is a positive relationship. Down left to right is a negative relationship. And the negative relationship is also called an inverse relationship.